Okay, now we're going to look at going in the opposite direction. We've been undoing radicals with the opposite action of squares or cubes or fourth root or fifth root, whatever we had to do to undo them. Now we're going to do the opposite, which is to undo square roots, to undo squares with square roots or cubes with cube roots, okay? So we're going to do the opposite, in other words. But on these, one thing we need to look at first, what happens when we says x squared is equal to a 9? What you're asking yourself is what numbers multiplied together equal 9, the same number? Well, you've got 3 times 3 is equal to 9, and negative 3 times negative 3 is equal to 9, which means we have both the positive of the root and the negative of the root, okay? Therefore, when we undo that, we are going to have to undo that square with the square root, but when we undo it here, you have to have both the plus root and the negative root, so you have to designate it. This undoes that, so x is equal to plus or minus the square root of 9 is 3. So that gives you both your positive 3 answer and your negative 3 answer. So as I said, note, a positive number squared gives a positive answer, and a negative number squared gives a positive answer, and this is why we have the two possibilities. Okay, some things to remember about this. For example, remember, an exponent of 2 is undone with a square root. So x squared is undone by a square root of that x squared. Whereas x squared plus 3 cannot be undone by the square root. Why? The x squared is not yet isolated. So again, this brings us down to the question, is the squared expression isolated? The exact same question that we had before. Okay? Is the squared expression isolated? And we will eventually get, the second question is going to change on this one because we're going to introduce a way to deal with these expressions that are not real number expressions, okay? So we'll get this. This is where we're going to introduce that idea. Therefore, in the real number system, remember, if you have a number squared, this number produces a positive number. So, in the real number system, x squared equal a negative number is not possible. But before we're done with this lesson, it's going to be possible because we're going to step outside of the real number system. But it starts by being in the real number system, okay? So let's look at those first. Let's start with x squared equals 49. Okay, undo that square with the square root, and don't forget your plus or minus. So x is equal to plus or minus square root of 49 is 7. And that gives you both your negative 7 and your positive 7. Okay, let's look at another one. X squared is equal to 19. Again, undo it with a square root and designate your positive and negative. X is equal to plus or minus the square root of 19, because we're looking at exact values. So you're not going to plug this in a calculator and get an approximation. You're going to simplify your square roots. So this means x is equal to a negative square root of 19, comma, square root of 19. Now, I don't know if they'll let you do the plus or minus in your MATLAB system. You can try it and see, okay? So, now let's move on to more complex problems. X squared minus 135 equals 0. Now remember, is your squared term isolated? Is the x squared isolated? No, it is not. I have 3 multiplying it, and I'm subtracting 135. So the first thing we have to do is isolate that term by adding 135 to both sides. And we end up with 3x squared is equal to 135. Now, we have to get rid of that 3, so our x squared will be isolated, and x squared is equal to 45, I believe. Yep, 45. Now our x squared is isolated, so now we can undo it with that square root. This undoes that, leaving x is equal to, this is 9 times 5. Square root of 9 is 3, and then square root of 5 will have to stay inside the house. So we simplify it to 3 square root of 5. So here our answer is plus 3 radical 5 and negative 3 radical 5. That gives you your 2 answers to this problem. X minus 4 in parentheses squared equals 16. Okay? Now, the squared part is isolated because everything inside the parentheses is part of that squared part. So again, we're going to undo that with your square root plus or minus square root of 16. The square root of 16 is 4, so this is plus or minus 4. Therefore, we have x minus 4 is equal to plus or minus 4. So this is much easier since we're talking about an integer over here. It is easier if we break it apart into x minus 4 is equal to 4, x minus 4 is equal to a negative 4. That way we will get both answers and one won't be forgotten. X is equal to 8. Add 4, and x is equal to 0. So as you see, you have 2 answers here, and they're not plus or minus the same number, which is why it really works better if you break this apart into 2 equations. Okay, let's look at another one. Okay. Again, our square is isolated, so we can go immediately to the square root of it. And don't forget your plus or minus. So I have x minus 6 is equal to plus or minus the square root of 11. 11 won't simplify, so that's as simple as it gets. Now when we add 6, these are not like terms, so they cannot be combined, and x is equal to 6 plus or minus the square root of 11. Or you can write it as x is equal to 6 plus square root of 11, comma, 6 minus square root of 11. One of them is the plus, one of them is the minus, and that takes care of it. Another one, 3x minus 7 squared equals 29. Again, note, the square is isolated because everything is inside the parentheses. So again, we're going to undo it with the square root and your plus and minus. So this gives us 3x minus 7 is equal to plus or minus the square root of 29. That's a prime number and it won't simplify. Now we need to isolate our x here by first of all adding 7 to both sides. And notice, these are not like terms, so they cannot be combined. 7 plus or minus the square root of 29. Now we have to undo that multiplication by 3 by dividing by 3. And notice it goes over, everything goes over the 3. So I now have x is equal to 7 plus or minus the square root of 29 over 3. This can also be written in several other ways. One is to write it simply as your 7 plus square root 29 over 3, and your 7 minus square root 29 over 3. We can also break it up like two different fractions. So we could have 7/3 plus square root of 29 over 3, and 7/3 minus square root of 29 over 3. All of these forms are correct, okay? So you can choose the form you like best.